Hi, welcome to Unit 2. So this unit is called Introduction to Front-End, but honestly, it's more like an introduction to everything. We're going to talk about three main objectives that we're going to use throughout the rest of the course. So it's a pretty important lesson. We're not actually going to write a lot of code. You'll be seeing code, but you're not going to write much of your own until the next unit. But what we'll start with is just setting up our own developer environment so that we can write code in the next unit. So we need to install Google Chrome if you don't have that yet, and then also Sublime Text so that we have somewhere to write code. And then the next thing, which is a really important objective, is to discuss the difference between front-end and back-end. So when someone says they're a front-end developer or back-end developer, or when I say that this is a full-stack developer course, what does that mean? And it's also important so that we know what we're getting into in the rest of this course. The first half is all front-end, the second half is all back-end, and really the last third is full-stack, front-end plus back-end. So that's important to understand what we're doing so that we have a little framework to reference as we progress. And then we're going to dive a little bit more into front-end specific technologies. So HTML, CSS, and JavaScript. We'll talk about what they are, how they fit together, what roles they play, how they're similar, how they're different, and really just dissect what they do. So that when we start HTML in the next unit, you'll have a little bit better of an idea of how it fits in with all the other pieces. And there's so much that we cover in this class that if I just went straight through and I just covered it all one after another without tying it together, without talking about how it all fits together, it wouldn't really be a great course. You'd be able to follow me, be able to do what I can do, but you wouldn't be able to actually write your own code, be a developer, understand how all these pieces fit together. So in this video, we're going to learn about two tools that we're going to use for the rest of this course. So when we make websites, when we're developing web applications, we need a place to write our code, which would be a text editor, and we need a place to view our code, which would be a web browser. So we use web browsers all the time. It's how you view the internet. It's how you're probably watching this course right now. And you're probably using your favorite web browser or the one that came with your machine. It might be Safari or Chrome or Firefox or Internet Explorer. There's a bunch of web browsers out there, and they all do basically the same thing. They let you view websites. However, we're going to use Google Chrome in this course for two main reasons. One is that we just want to have a standardized browser so that if I do something, I show a shortcut, I show the developer tools, I do something with one of the menus, that you can replicate it yourself. And the other reason is that Google Chrome is used by a lot of developers. So as I mentioned, you can use any of the browsers, but generally most developers are using Google Chrome or Mozilla Firefox. Both of them are solid offerings, especially with their developer tools, which we're going to learn a lot more about as we move forward. But basically, dev tools are tools that are made for developers. So things that you may have never seen before because you haven't been a developer. But as soon as you start this course, we're going to be using a lot of the tools that Chrome gives us that are a little bit hidden that help us make websites. So go to the Google Chrome website. It's google.com/Chrome. It's in the description as well. And download the version for your computer. So for me, that's going to be a Mac. For some of you, that might be a PC. You can click on download another platform and choose the correct platform. Download that and drag it somewhere or install it in a folder that you'll know how to find it again. I would personally recommend using Chrome a lot if you're not used to it. Use it to do your regular internet browsing. Try and make the browser that you develop in the same browser that you actually use to browse the web. There's no reason to use Safari for some things and Chrome for others. The other tool that we need is a text editor. So this is a really important tool. It's where we're going to write our code. Technically, we could use any text editor out there. So you could write code in Microsoft Word. You could do it in a Google Doc. You could do it in a $500 professional code editor. There's all sorts of different platforms. And honestly, every developer has his or her own opinions and his or her own setup that they swear by. Personally, I prefer teaching with Sublime Text, which is a free text editor. Well, it has a free trial that goes on forever. I definitely recommend paying for it if you end up doing this professionally, but the point of the trial is that anyone can use it. It's an open platform. It has lots and lots of people using it, and as I mentioned, it's free. So sublimetext.com and click on download here. We're going to do version 2. There's also Sublime Text 3. Which is in beta. It's been in beta for a really long time. It's pretty stable. So if you want to use Sublime Text 3, go ahead. Great, so we'll go ahead and download this, click on the correct version, get that downloading, and those two tools are going to be really, really important. Welcome back. So this video is going to function as a sort of crash course in how the internet works. for someone who wants to be a developer. So it's meant to take you from avid internet user like me, who maybe doesn't understand a lot about how the internet works, because you don't have to someone who still uses the internet all the time, but understands a little bit about how it works at a high level. It might be surprising, but developers really don't need to know the very low-level nitty-gritty about different data protocols and how they work and this TCP/IP stack and things that you may hear that are very intimidating. That's an entire discipline. There's entire college majors and courses devoted towards how the internet works at a low level. As a developer, things are abstracted away so that we only need to understand the very basics more than your typical user of the internet, but we don't have to be experts on all this very intimidating nitty-gritty stuff. So a few things we want to do here. We want to understand at a high level how the internet works. Things like HTTP, IP, domain names, URLs, what are all those? How do they work together? We want to understand the difference between front-end and back-end development. Also full stack, where does that fit in? And then we also want to be able to view the HTML on any website. So the first thing that I want to do here is actually watch a video. So the link is in the slides. It's also in the description of this video. I'm going to go ahead and open it up. Feel free to watch this on your own. I'm going to watch it in this video and just pause at a few moments, highlight a few important pieces.
Have you ever wondered what happens when someone in England visits the World Science Festival's webpage? First, their computer needs to ask the World Science Festival server for a copy of that webpage. The computer sticks this request into a virtual envelope called a packet, wrapped with specific information about that request, including the World Science Festival's IP address. The computer sends this packet out of the house and below the street via large underground copper wires. It passes through small regional networks before ending up here at Telehouse North in London. Telehouse North is England's main internet hub. The IP address on this packet tells the hub that the World Science Festival server is actually in Los Angeles.
The first thing I want to just highlight there, the user in this case went to a website, World Science Festival website, or typed that in and then hit enter. And all of this is happening before the user sees anything. The idea is that a user is asking for a website or requesting it, and that's what it's called. It's an HTTP request. So when I opened up this video, youtube.com/this URL, when I hit enter, I'm asking for the contents of this page. And that has to go all the way to YouTube somewhere, and they have to send it all the way back to me. So far, we're still just getting the request to the right place.
So Telehouse North sends the packet out as light across the Atlantic, over fiber optic cables buried deep beneath the ocean. The packet ends up here, 60 Hudson Street, New York City, the largest internet hub on the East Coast. This hub sends the packet through a series of regional networks connecting New York to Los Angeles, where the World Science Festival server resides. The server reads the request and gets ready to send the web page to England. But web pages made up of images and text are too large to send as a single packet of data. So how do we get it back to England?
So at this point, the request has made it all the way to the correct server, and it's told it, I'm looking for this page. And so now everything is on the return journey, going from the server all the way back to the computer that asked for this specific page.
Group of 5,000 tourists visiting New York City in a single gigantic tour bus. They are way up in Harlem, but they want to visit the Statue of Liberty before it closes. But it's rush hour, on a Friday. There's no way that giant bus is going to fit through those crazy congested streets. So they decide to get off the bus and spread out. Some take the subway, some take cabs, a few rent bikes, and some even take kayaks down the Hudson River. How they get there doesn't matter, as long as they get there on time. Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England. The packets are sent to LA's One Wilshire hub, which checks the traffic report before sending them off. Through miles and miles of land they travel, checking in through different hubs. Like our New York City tourists, those packets don't care how they get there, as long as they get there as fast as possible. Most of them will go through 60 Hudson in New York, where they are redirected back to England as light, riding a fiber of glass as thick as a silver dollar. Then back on copper wire through regional British networks until all the packets reach their destination and this epic journey, it all happens in about a second, along with trillions upon trillions of similar journeys that happen each and every day on this remarkable, easy to take for granted network of networks we call the Internet.
So hopefully you found that video fascinating. It certainly blows my mind, even, to someone who does this a lot and who uses the internet a lot, makes websites, makes applications. It's still so amazing, the process that happens behind the scenes, just for every single page that loads. Just to reiterate, let's take this example of when I go to this URL, udemy.com/courses, and I hit enter. Remember, I'm asking for something and I'm getting something back. I'm requesting something and a server is responding. And there's a lot of stuff that happens in between, but that's the core concept. So the very first step that happens, and actually before I start there, I want to let you know, this is not something you need to memorize. This is purely conceptual stuff that is nice to know, but you can always come back, you can look this up, you can rewatch this video. The one thing I really want you to memorize and to be confident in is this idea of requests and responses, asking for data and a server giving you that data, and then your browser displaying it. So this step here, when I go to a URL, I hit enter, the first thing that happens is my computer needs to know the exact address to send a request to, which is just like when you send a letter, you need to have a unique address. No home has the same address as another home. They might look the same, but they're in a different city or different zip code or a different country. They are unique. So we need that address so that our request goes to the right place. So this thing called a DNS, it takes that domain name, udemy.com, and it translates it into this IP address, which is a string of numbers and dots. This is a unique identifier. Once we have that, then we actually send the letter. It's when we actually make the request. So in this case, when I hit enter, I am figuring out, or my computer's figuring out, what is www.udemy.com's IP address. Okay, we have the IP address. Now let's send a request asking for the courses page. So we make a request with an HTTP request. We'll talk a lot more about what that is and what they look like. And remember, it's not just one way direct shot there. Basically, the request bounces around from server to server until we get to the server we're looking for. So when we get to the server, the first part is that the server is going to figure out, what am I asking for? Am I asking for the home page? I'm asking for /courses page. Am I asking for the sign up page? The become an instructor page? There's all sorts of different pieces here that I could be asking for, and they're all different. So the server's job is to figure out what to send back. When we do backend development, that will be your job, figuring out what content to send back. So then the server often interacts with the database, it pulls out information, and it makes a combination of HTML, JavaScript, and CSS. So then our server responds back. It sends us this combination of HTML, CSS, and JavaScript. It's a bunch of code. It's not very readable for humans. And our browser steps in and it turns it into this. It's the whole job of our browser. It takes that information and it makes it easy to understand for humans. So this process happens on every single page you visit, and you can actually see the underlying HTML and CSS on any page and JavaScript. So there's a few ways of doing it. In Chrome, and this is why we're all using Chrome, you can go, let's go to this page here. I can right click and click View Page Source, and it opens up a new window that actually contains all of the HTML, CSS, and JavaScript that is the underlying source for this page. Same thing on YouTube, right click, View Page Source. And so this is on every single site. So there's no way to hide this. The whole job of the browser takes this and it turns it into this. So browsers are definitely complicated things. The good thing is you don't have to know how that works. The browser, that's the whole job of a browser. It takes that code and it turns it into this. So another way you can do it, there's a shortcut in Chrome. You can do Command Option U, On a PC, I believe it's Control-Option-U. If not, you can just right-click in Chrome and view it as well. Welcome back. So in this video, we're going to focus on the front end. We're going to learn about HTML, CSS, and JavaScript on a high level. We're not going to actually write any code yet, but we will be seeing code for the first time. So there's two big things we want to know, which is what's the difference between front end and back end? And then also, what's the difference between HTML, CSS, and JavaScript, and what are their respective roles? So let's start by discussing front end versus back end. So when I go to a URL, let's say I go to Facebook. I hit facebook.com, I hit enter, and if you'll remember back to the video on how the web works, I create a HTTP request asking for facebook.com. And that goes to Facebook's server eventually. Facebook then decides what page to send me back. So in the case of Facebook, it needs to figure out what images, what stories, how many likes they have, what friends I have, what posts are at the top, all my settings, my profile pictures, all the stuff that pertains to me. And then it sends it back to me, sends me HTML, CSS, and JavaScript, and my browser displays that for me. So this diagram here kind of just explains the difference between front end and back end, where everything that I get back and that I see in the browser is just HTML, CSS, and JavaScript. It's just the tip of the iceberg, but it is what my browser sees. It is the front end or the client side. It is constructed by the back end. Everything else that happens, all the logic, figuring out if I'm logged in, figuring out who my friends are, what photos I have, what posts I've posted, how many likes they have, all of that comes from the back end or the server side logic. So you can see there's a lot more here. The technologies, there's so many choices. On the front end, there's not. It's always HTML, CSS, and JavaScript. On the back end, you've got different languages like Python, PHP, Ruby, JavaScript actually, which is what we're going to use. There's different databases. You've got Postgres and Mongo and CouchDB and MySQL and SQLite. And there's so many choices. So it's a little intimidating. We're going to definitely talk a lot more about the back end when we get to that unit. But for now, just remember that the back end is what constructs the HTML and the CSS that is sent back. So let's take an example here. One of my favorite restaurants in San Francisco is called Lazy Bear. Here's the restaurant page. This page is always the same. I mean, it could be changed, but in order for it to be changed, the developer has to go into the HTML and manually change it. So basically, I refresh the page every time. I get the same homepage. I get the same frequently asked questions, the same contact us page. That's not a bad thing, but it doesn't need to change. It's just a restaurant web page. However, the Yelp page for Lazy Bear is dynamic. It does change. So anytime a new review is written, it's going to show up here. Every time, and let's say in this case, let's rate it 5 stars. I write a review. Well, Yelp will probably reject my review, but if I wrote a review, it would show up here. Things are dynamic. They're happening at all times. So I could say, oh, that was a useful review. That was a funny review. And those votes that I've added are stored in a database. Something is happening. I'm interacting with this, and it is persisting. So if I refresh the page, now it's different. Not very different, but whereas before I didn't think this was funny, now it remembers I thought it was funny. So basically, the point is, when I go to this page, I ask for this URL, Yelp doesn't just always send the exact same thing back. It's going to figure out, okay, is the user logged in? If so, we want to put his profile picture up here. Has he voted on anything? Yes. Okay, let's make sure that we highlight it correctly, change the color, don't let him vote again, and so on. And then it constructs HTML, CSS, and JavaScript, and it sends it back. So another example of a page that is definitely dynamic is Google News. Every time I refresh, almost every 5 minutes something changes on here. Whether it's the weather over here, NFL scores, these are live updating. Maybe it's the news story, there's breaking news, something changes. This is very, very different every time. However, this is always the same. So again, the difference is 2 things. One, a static page versus a dynamic page. Both of them are web pages. Both of them are HTML, CSS, and JavaScript coming back. But one is going to change based off of some sort of server-side code, something on the back end. So I also like this analogy of a restaurant. So if you imagine you go to a restaurant, you sit down, let's say you order a steak. When you order that steak, you're making a request that goes back to the kitchen. The kitchen prepares everything for you. That's sort of the back end. It decides what ingredients to get, how long to cook them, plates everything on a plate, and then a waiter or waitress comes and brings that to your table. So it's very similar. You make a request. The chef or the kitchen is the server, this part of the iceberg that is concocting everything, cooking it, putting it together, and then finally it is sent back to your table, which is you on the client side. So now let's break down those three pieces, HTML, CSS, and JavaScript. So we're going to go into a lot of detail on each of those components. They're separate sections and units, but HTML, let's start there, stands for Hypertext Markup Language. Basically, imagine that, and this is what actually happened, in the early days of the internet, there was no standardized way to send information and to send documents. So initially, the internet was used to send, to communicate between universities and colleges, and also as a military tool. So let's just say I wanted to send this to a friend. I need to say, okay, this is bolded. These are little bullet points. I've got some text and quotes around this. I need a way to break that down and describe it to send to somebody else. And the solution was HTML. So HTML it's actually the easiest thing that we're going to learn. Not to say that it's insanely easy, but it is very simple in that we just describe what we want. And what you write is what you get. So HTML is often referred to as the nouns of a web page. It's the structure. Some people say the skeleton. Basically, you say, put an image here, put a bullet point here, put a heading here, put a slightly smaller heading just below that. It allows you to describe the structure of a page. CSS, on the other hand, is how we describe the style of a page. I need HTML to use CSS. CSS on its own doesn't really do anything at all. Every single web page has HTML. Some web pages don't have CSS, some don't have JavaScript. It's not mandatory. HTML is. So CSS, cascading style sheets, we'll learn exactly where that name comes from in a little bit. Basically, it styles existing HTML. So you can say things like, make all those bullet points green, give the first image a yellow border, give the last image a big pink border with dashes through it. It's often considered the adjectives of a web page, or some people would say the skin to the HTML skeleton. And the last piece here is JavaScript. JavaScript it's definitely the most complex thing out of these three. It's how we add logic and interactivity to a page. So with CSS and JavaScript, we can make a beautiful looking site, but it's not going to do anything really. We can do simple animations, but we can't load data from somewhere else. We can't make things interactive. We can't add logic or have a game. With JavaScript, we can. Some of the examples I have here are do some math, change color when the user clicks, load new data from Twitter, get the current weather or the current NFL scores. If HTML is the nouns, CSS is the adjectives, then JavaScript is the verbs or the actions on a page. So I have this all wrapped up nicely in a CodePen. So CodePen is a wonderful site. We're not going to use a whole lot, but because we haven't really started writing HTML, CSS, and JavaScript, I'm going to use this as an example. And what this does, it lets you just write simple pages in the browser. So we don't have to use Sublime Text. We just write it in the browser, and I can share it with you very easily. I have three sections, HTML, CSS, and JavaScript. Again, the code itself is not what's important here. It is the concepts. So let's take a look. And I'm going to actually get rid of my CSS. I'm going to get rid of my JavaScript. And you'll see what we're left with. Plain black and white structural material. I'm specifying my content. So these are my words. And I'm wrapping that content in specific structural elements. So an H1, and again, this is one of those times, don't worry about the specific syntax. We have so many videos ahead that are going to go into detail on each one of these. But basically, this is saying make big text right here. This is saying make a list and make an individual list item that says make me a bullet point, and another one that says make me another bullet point, and then make a button that says make me a button here, as you can see. So on its own, that is just the structure. So now let's go add our CSS back in. You can see what I'm doing here. I'm saying make the H1, which is here, make it purple. So we could change that to be green. And it changes to green. And I'm also saying make the button have a border, have a background color, and a text color of white. So we can change that to be green text color. It's hard to see, but that changes to green. I can give it a much bigger border, 20 pixels, as you can see there. So that's our adjectives. And the last piece is our JavaScript. So without JavaScript, that button does nothing. Now what we've done is written JavaScript that says when the user clicks the button, pick a random color and change the background color here to that random color. So I'll show you that. I can click and I get a random color. So if I got rid of this JavaScript and I tried to do that again, nothing happens because I don't have any verbs. It's just nouns and adjectives. It's just the structural skeleton and a little bit of skin on top. As I add my JavaScript in, I can add the logic. So JavaScript's really important. This isn't exactly what you would do most likely on a real production site, but you would have maybe a game. You might make Minesweeper. This might be Facebook chat. It might be a form to sign up for a page. You use JavaScript to make it interactive. So again, I encourage you to play around on CodePen. You have the link to this and explore a little bit. There's no rush to move ahead to the next video. Try changing some of these colors if you want. Try changing some of this. Don't focus on the code. It's just fun to play around with. But there's no pressure to understand any of this aside from a very high level overview of what HTML does, what CSS does, and what JavaScript does. All right.